So we start the session with the first talk of the morning by Matteo Guainazzi, who will update us about the Athena Observatory and talk about its science objectives. One thing that Matteo will start by updating us on the status of Athena, and then we will stop a little bit for questions. So if you have questions to ask to Matteo about the status, you will have the opportunity during his talk, and then he will resume with the scientific objectives of the missions we are all familiar with. Thank you very much. Matteo, the floor is yours.
It was at an XMM Newton conference a few years ago when I stood for the first time giving my first talk on Athena. And at that time, a young colleague, I don't remember if she was Victoria Greenberg or Margherita Giustini, they tweeted that I had said something along these lines. The fact that I'm standing in front of you to talk on Athena shows that Athena is healthy and in good shape. That's what I said. Now, with time passing by, I have become wiser, maybe less ambitious, and my message today is the fact that I'm standing in front of you talking about Athena means that Athena is still alive. But let's not jump to the conclusions too fast. And first of all, thanks for inviting me to give this talk. I'm Matteo Guainazzi. I'm the Athena study scientist at the European Space Agency. My goal today is to go through two topics. One is the status of the mission, and the other one is a sort of update of the science objective of the mission in view of the status of the demonstration of some key technologies enabling the mission. So let me start straight away with the first point. You all know, for reasons that will be obvious in a second, that we have gone through a few exciting weeks in the project. And the main root cause of that is that the science program of the agency is in quite some distressful financial situation. And Athena is part of the problem. The current estimates of the Athena cost to ESA exceeds by 80% the cap that was originally set by ESA for the mission. So in order to address this issue, ESA presented a proposal to the Science Program Committee, which is essentially the board representing the member states of the agency, to solve the problem of the science program. And among other things, this proposal would have implied the suspension, that's the word used in the paper, of the Athena project. Now, there is a body appointed by ESA of scientists that represents the Athena community, which is chaired by me, the Athena Science Study Team, and they have the mandate of advising ESA on how to run the mission. And they took two initiatives. One is to prepare a paper proposing an alternative way of addressing the financial issue of the agency. And the other action that most of you aware of is to start a petition to ask for support for the concept of Athena as an X-ray flagship mission, which was signed in just 1 week by over 3,200 scientist colleagues. Now, the SPC, I said, is the ruling body of the European Space Agency science program, took a series of decisions. So Athena is still alive in the sense that it's not been suspended or terminated. However, Athena will not be adopted in June 2023 at the current level of resources. So you may remember that the adoption shifted from November 22 to February 23, then it was June 23. Now adoption is not going to happen in June 2023. And Athena will need to save money. We need to save money because in this moment the cost is unaffordable for the agency. Now, the process how to achieve this money saving is still to be determined. ESA is preparing an action plan or cookbook, I read yesterday it will be called, to be discussed with the SPC and the member states on which process it will be followed in order to achieve these cost savings. So I know nothing about this plan because nobody knows nothing except probably the person who is drafting it. But we assume that the ASST and therefore the science community will be involved in one way or the other in the process. But I don't know how yet. And the important point is that there is a cost cap to this exercise, but it's not a cost cap on Athena itself. You know that Athena is a large class mission of the agency, and there is another large class mission of the agency, which is LISA, under study, and the total cost cap of these two missions has to be 2.6 giga euros, so 2.6 billions, the common cost cap. But there is no a priori fixed ratio on how this split should be made, how much each mission will get. So this process will have to end by the end of this year, more or less, and at the beginning of next year, at the latest, ESA and the SPC will take the decision of which of the two large class missions will be adopted in 2023. And the other one will be adopted later. Later means to be seen. Now, of course, it's not easy to save a large amount of money on a space mission, and there are options to save money that are, in principle, science neutral. You know, if we can save, I give you an obvious example, if we can save money on the launcher, for instance, in one way or the other, that would have probably almost no impact on the science. But most of the options, most likely, will have an impact on the science. That's something that we have all to be aware. It will be a complex, difficult process. It will have an impact on the science performance of the mission. Which one it will be and to what extent is, of course, unknown at this stage. And, of course, the ASST is there in order to make sure that whatever decision ESA is going to propose, the SPC, and is eventually taken, minimize the science impact of the mission. But I don't want to fool you or to sell false illusions. There will be an impact on the science of the performance scientific of the mission. That's the expectation. Now, as said, that's the first part of my talk. I want to stop here now and get any questions you may have on this point, because I'm sure that this summary leaves many questions to you. I have then a second part of the talk that I'm really glad, I'm really willing to shorten to give as much time as possible for questions that you may have on this point. So don't hesitate, don't be shy, please feel free to ask.
So we start as usual.
So one of the things I didn't understand was the Athena cost to completion suddenly increased by $500 million in a way I did not understand. What happened?
So, of course, suddenly is suddenly to us, but not suddenly to ESA. So the cost increased in several elements essentially because we have now more reliable cost of critical elements coming from industry. So the reason why these numbers are known now is that they are related to the mission adoption review process. So the mission adoption review of Athena actually started in May. And in the framework of this process, we got the most reliable estimate from all parties, in particular from industry, on elements that are particularly expensive. And it's not the first time that happens that when we have more reliable cost, they are higher than you had estimated originally. So the reason why this number counts now are due to the fact that the process in order to evaluate the cost in the ultimate reliable way has just started.
My follow-up question is, But then my follow-up question is, Athena's sort of further along this process than LISA is. So we have actually, the same thing is going to happen to LISA, and LISA's costs are also going to jump by $500 million at some point when they get reliable costs from industry. Yeah,
of course, I'm not here, I can't speak on behalf of LISA, of course. But what I can tell is that it's not by chance that we have a common cost cap between the two missions. LISA will also have to go through a process where the costs are seriously reviewed. And let's say it's unlikely that LISA is not also, will not also to make some efforts in order to save money. But, that's not, I would say, as an Athena community, we should not look at LISA as an excuse and not to do our homework in the most detailed and reliable and thorough way.
Hi. Yes, I have in mind that actually Athena was in advance. The project was in advance compared to LISA in terms of phase B.
Yeah, correct.
So what I don't understand is that why this is not taken into account. Apparently, because they put the two missions at the same level, if I understand correctly. So why? It's
Well, no, I don't. First of all, of course, the first statement is correct. Athena is in full phase B1. Whereas ELISA has just completed phase A, so they start phase B1 now. But it is taken into account because, as I said, there is a common envelope, and also LISA will have to scrutinize their cost.
Yeah, but in terms of schedule, then in terms of schedule, one of the two missions will be chosen in 2023.
Yes. Well, the adoption of Athena, of LISA in the previous schedule was foreseen in, I think, the first SPC meeting of 2024. So,
what I see that we should probably try to understand better is because of this different schedule. I mean, 3 months ago, we thought that Athena would cost at most 1.5 billion. And probably LISA will know that it will cost 2 billion in December 2023, while the decision will be taken early 2023. Which is something that probably we should stress. I mean, the decision on Athena will be based on reliable costs. The decision on LISA will be based on costs that will increase a lot. Not because they are stupid, just because this happens.
Well, if a LISA, I'm not here to talk about LISA, just to make sure. There is a LISA study scientist at ESTEC, you can ask him. But, if LISA was going to be adopted in 2024, let's say first SPC, this means that they would have started a mission adoption review in first or second quarter of next year. So, it's not a big schedule difference. I don't want to say that it's a completely easy process for any missions in the agency in this moment, but there is not a several years discrepancy between the current schedule and the original schedule. This is an argument we shall not use as a community.
Okay. Further questions? Yes.
So I think it's really important that we do Athena in a timely fashion. One of the things that can happen with budget is it just slips and slips and slips into the future. And I think the science case then gets eroded because other agencies will fly things in the meantime. And so how is it actually better at this stage to do something quite drastic to make sure that Athena goes in a timely fashion?
That's the drastic action. We are asked to shave 30%, or the order of magnitude of 30% of the Athena cost. That's quite radical.
Does that mean we should actually think about going to one instrument rather than two?
Okay, that's an interesting question. Let me face it straight away. Athena is not just an X-ray observatory of the European Space Agency. Athena was selected to address a very specific science case, which is the topic of the hot and energetic universe. And I don't need to convince anybody of you that if you want to do the hot and energetic universe, you need a spectrometer, much better than any spectrometer has flown so far, plus a wide field imager on the focal plane of a larger telescope. This is Athena. If we change the payload configuration in any significant way, this is no longer Athena. This is another mission. This decision can be taken by the agency at any time, of course. I don't say that that's not a potential solution, but that would be another mission with another process. So it's not that we can switch Athena to another mission as if nothing would have happened. We'll have to define a process going from Athena to another mission. And this would take time anyway.
Right. Because I think we gain so much because it is an observatory for the whole X-ray community. But at the same time, there are, if it made it simpler, cheaper, to split it in two, to maybe go to some other agency like NASA and say, what are you planning for your probe class? And if a significant section of the science could be done in that way, if it would make Athena, or whatever we call it, quicker, cheaper, is that worth exploring?
Yes, but I say, this is another mission. You know, I'm wrong, I'm the right person to ask. I may not be the study scientist of this other mission. So it's not, my task is not to advise the community what to do. If this is a way the community thinks interesting, the community should tell ESA. But it's a different mission, it's a different process. I don't think the Athena community has any interest of going this way if we want to keep Athena as the mission addressing the hot and energetic universe science team.
Is it possible to save $500 million without doing that?
I will tell you in 6 months. I don't know in this moment, and nobody knows. But what I can tell you, which is surely in this situation a positive message, is that I have seen in the last week lots of whiteboard thinking on how we can rethink Athena, so in Athena with the two instruments and the SPO mirror, in a way which could save a significant amount of money. Now, whether this is technically possible, programmatically possible, scientifically appealing, it's all to be discussed. But the process has started. And I think it would be unwise not to support it, also because for me the key point is this one. It's not an open-ended process. If by that time we have not reached a convergence with a mission profile which is Athena, but is at the same time scientifically appealing and programmatically possible, at that point it's not unclear to me how we will go. But we are bound to this decision point. Beyond that, of course it's a decision by ESA, by the member states, but if they ask me an advice, I don't want to drag this process for years waiting for a convergence. Either we achieve a convergence now, or my personal advice, I'm not now talking on behalf of ESA or any member states, my advice would be stop and do something else. But that's my own advice, the last statement I take only on my own responsibility, it's not on behalf of ESA. But what ESA say is that that's the deadline for the process to be completed.
Any other questions for Matteo? If not, we can carry on
okay.
Scientific objectives.
Just to get some water, because
yes.
Otherwise... Thank you. And now for something completely different, some science. So, Giovanni, how much time do I have? Okay, that's enough. So, of course, my goal is not today on the science to tell you about the science case of Athena for two good reasons. It has been well known, and you made it, I didn't. So let me just remind you some basic questions. My goal today is to try and link some key science cases of Athena relevant to this conference, so accreting black holes, with some level of technologically demonstrated performance of the mission at the stage where we are, so in phase B1. So the main questions that Athena is going to address that are relevant to this conference are, we want Athena to contribute to constraining the distribution of seed-accreting black holes that are the original distribution of black holes giving rise to the large quasars of billion solar masses black holes that we see in the early universe. We want to unveil the full census of the obscured phase of black hole accretion until redshift of the order of 3. Establish the role of black hole outflows, of which we had so many interesting talks yesterday in AGN feedback. which means looking at this kind of outflows not only in the local universe, but where the peak of the AGN activity occurs. Establish, providing clues on the path of evolutionary of the galaxy that hosts the black holes through measuring black hole spin distributions in the local universe, and study accretion phenomena over the whole black hole mass scales, from stellar mass to supermassive black holes. And as a bonus, also extend the study of the transient universe and multi-messenger astrophysics to a new dimension, literally. So the basis of doing that is creating a large sample of accreting black hole detected in X-rays, covering a parameter space which has been unexplored so far. In the nominal phase, operational phase of 4 years, Athena is expected to detect something of the order of a few 100,000 AGN in the sky. Now you can say, well, that's not impressive. In 2 years of scanning, E Rosita actually detected 1 million. So what's interesting with them? And the fact that is interesting with them is that the current facilities, including E Rosita, that are shown by the black dots the orange contours is Rosita, and the black dots is an old compilation of Chandra and XMM Newton survey, can only reach with their spectroscopic measurements up to zeta of the order of 3, more or less, with a few objects beyond that. But with Athena, we aim at collecting a sample of AGN, which extends well beyond the epoch of ionization, with 10 of objects in the Seyfert-like regime at redshift larger than 6. And this will allow comparison with cosmological simulations with different black hole seed distributions. So why I'm stressing the Seyfert-like regime luminosity, 10 to the 43, 10 to the 43, 4, at redshift larger than 6? Because this is exactly the regime of luminosity which has the most constraining powers from different models of distribution of the observable observed quasars at this redshift, depending on different models of black hole seed mass, black hole seed redshift injection, and accretion property, accretion rate. So if we can detect a sufficient numbers of AGN at the luminosity of 10 to the 43 at redshift larger than 6, we will be able to constrain models. If we look at objects at higher luminosity, it will be much more difficult for Athena to contribute to this field of science. And the way of doing it, of course, with the WFI imager, so with a wide field imager that is able to detect in a single pointings more than 1 order of magnitude more sources that Chandra and XMM can do now, as shown in this histogram, where you can barely see in blue and the sort of olive colors the distribution of fluxes that deep observation with XMM and Chandra is able to obtain, in compared to the huge number of sources that we expect from a single moderately deep Athena pointing. And of course, the key point in Athena being able to do that is keeping the confusion limit at bay. And the confusion limit is primarily dependent on the angular resolution of the optics. So we know which is the requirements for the optics of Athena, on which basis this set of science requirements was defined, which is 5 arcseconds pulse energy width off-axis. And the SPOs have the nice properties that the degradation of the angular resolution off-axis up to the edge of the WFI border is actually very mild. It goes, if the center is 5, at the edges to 6.5, 7 at most. So we have, on the average, on the Athena WFI, a much better PSF than on the average in Chandra. But we have not reached yet the level of angular resolution performance that we need. This is a plot that shows the measured angular resolution of a stake of representative Athena optics from 2021 to now, so in the last 14, 15 months, more or less. And there are several different points in this graph, but if you concentrate only on the blue points, you can clearly see recognize that there are 3 regimes in this plot. What happened prior to July 2021, when ESA stated that the level of demonstrated performance were 10 arc seconds, half energy width. And what happened until essentially May this year, so May this year is essentially now, when actually ESA stated that now we have demonstrated a level angular resolution of 8 arc seconds. Now the blue rectangular box highlights the latest measurements that suggest that improvement is still happening. So if the technology development program of the OPTIS continues, and of course depending on when the adoption date happens, we are still on the way to reach, if not the requirements, at least a level very close to the requirements. Why is this important? Because in particular for the high redshift AGN, the capability of Athena of fulfilling this science case is a linear function of the angular resolution. If we use as a metric the amount of time that you need in order for the WFI survey to detect a certain number of AGN in the critical redshift and luminosity range, this time increases essentially by a factor of 2 if we go from an angular resolution of 5 to an angular resolution of 8. And this may mean going from a survey that requires 15 megaseconds to a survey that may require 40 megaseconds or more, which is, of course, very close to being impossible to do, at least in the nominal phase. So it's very important that this program continues in order to achieve a performance which is as close as possible to the requirement for the amount of time of the WFI survey in order to achieve this objective to be compatible with the nominal operation life of Athena of 4 years. Another science case which is affected by the angular resolution is our capability of detecting the obscured phase of accretion of black holes up to redshift 3 through moderate resolution spectroscopy of Compton-thick AGN like this. Now, this is also a case which is at the core of the Athena science case, which is affected by the angular resolution for similar reasons related to the confusion limit. But since in this case we are dealing with sources which are a bit brighter than the sensitivity limit of the mission, in this case the impact of the angular resolution is much smaller. Is at the level of 25% of the total time of the survey if the angular resolution is at the level of 8 arc seconds as currently demonstrated. Another key core element of the AGN science case of Athena is AGN feedback, which can be either radio mode feedback or quasar mode feedback. And the radio mode feedback, so essentially the goal that Athena will be able to detect to make spectroscopy, spatially resolved spectroscopy of cavities and shock fronts and other structures that are the signature of the interaction of the radio jets with the intracluster plasma. This actually is also limited by the angular resolution. If we have an angular resolution poorer than the requirements, the number of objects where it will be possible, to perform a spatial resolved spectroscopy like in the simulation of Sinus 61 that I'm showing here on the left, will be limited to a few objects. However, the more traditional quasar mode that was the subject of most of the talk yesterday, being made with sources which are point-like and relatively bright, is not affected substantially by the angular resolution, but is affected by the effective area, especially in the hardest energy band. Now, of course, this is not surprising because besides the angular resolution, one of the key, if not the key element of Athena is being a large mission. A large mission means a large telescope with the largest effective area ever studied and ever conceived in practical terms, exceeding by more than 1 order of magnitude the effective area of any planned or existing X-ray missions, which translates, as the right plot shows, in a capability, for instance, 10 times better of detecting weak emission lines by the Athena X-IFU with respect to, for instance, the CRISM resolve. So the X-IFU instrument of board on Athena is designed to be the most accurate X-ray spectrometers ever in the focal plane of the most powerful X-ray telescope ever studied. So this is why effective area, of course, is so important. And one thing that we have learned at the status of phase B1 is that due to a combination of lower estimates of the effective area and lower estimate of the mirror and lower estimate of the instrument efficiency, our prediction of what the effective area of Athena will be goes below the expectations by a factor which is dependent on energy. We have a shortfall of effective area at 1 kV of the order of 10 to 20%. And of course, this is not something I lose my nightly sleep. But more seriously is that we have a 40% shortfall of effective area in the prediction with respect to the expectation at 7 kV. Now, this is a fact of life, so there is really little that we can do at this stage in the current design in order to resolve the shortfall, but there is a technical solution. And the technical solution is multi-layer coating, which is essentially a clever way of coating the mirror module of Athena in order to have a localized enhancement in a small energy band that allows you to recover a substantial fraction of the effective area of the order of 30, 40, 50% in a specific energy band. And the ASST has recommended ESA to do that in a band centered around 6.5 kV in order to maximize the impact on the overall Athena science. And this is now in the plan, in the technology development of ESA. It is not been qualified yet. It will be whether it will be qualified or not, of course, it depends on how much this technology development activity will be continued. And of course, I cannot give a talk at the conference of supermassive black holes without mentioning the measurements of the black hole spin in the local universe, which is, of course, something that Athena is posed to do in an unprecedented way, essentially for the capability, due to the combination of effective area and angular resolution, to distinguish, to disentangle the effects due to the relativistic reflection from the effects due to ionized outflows. And this will allow Athena to get a distribution of the black hole spin in the local universe that can be compared with models of cosmological evolution of black hole hosting galaxies. And a recent paper by Didier Barret and Massimo Cappi showed that we can get the typical black hole spin errors with X-IFU that goes from 0.1 to 0.2 over the whole black hole ranges. And of course, for very small black hole spin, these numbers are the order of 0.05. Now, is this true? Now, there is an interesting paper published by Michael Parker a couple of weeks ago that warned us that life cannot be easier even in the Athena realm. So there might be still a degeneracy in our capability of disentangling outflow models from disk reflection models, even with Athena spectroscopy. And this may create a bias in the determination of the spin towards higher spin values. Now, there are mitigation strategies possible. One is using prior on your contribution of the relative contribution of the two components using X-ray broadband spectroscopy if there is a new star-like mission flying by the time, or multi-wavelength priors, the famous UV scaring message coming from somebody in the audience. But the point which from my perspective is the most interesting and on which we have as a community a few years to think about is how to refine our timing, spectral timing capabilities. There was yesterday an initial interesting discussion of the statistical issues related to spectral timing, simultaneous fitting, and I think we should spend the community more time and more resources to figure out a scheme which is at the same time feasible but also statistically rigorous. And last but not least, I think a question that everybody who is going to scrutinize in the future Athena will ask is, okay, fine, what do you do eventually 400,000 AGN? You're not going to observe 400,000 AGN just to use a few hundred at the redshift larger than 6. And Guido has a solution for that. And of course, you can do many, many, many things with 400,000 AGN. But with larger sample of AGN, only with Athena, you will be able to create a Hubble diagram for quasars, which actually cover a redshift range which is competitive with respect to other techniques to measure the distance scale of objects in the universe. And actually, this simulation that Guido has provided me with, shown here, actually shows that with the Athena FI survey, we can actually build this Hubble diagram of quasars until probably redshift 4 or 5. But they say it's not only AGN. Athena will be wonderful also for stellar mouth black holes, thanks to the defocusing capabilities. Oh, the scoping, that's a nice Freudian, yeah. So thanks to the defocusing capabilities of the mission, we will be able to observe objects with a flux of the order of 1 crab with a throughput of 80–70% at a degraded resolution of 10 eV above 5 kV. And you know, it's funny to think of something like 10 eV resolution in this energy band as a degraded energy resolution, because of course it's much better than anything we can get nowadays with CCD spectroscopy by at least 1 order of magnitude. And maybe if, as I truly hope, we will be able in the future to fly together with LISA, we maybe will be able to do even more exotic and honestly speculative things, like being able to detect the counterpart of spiraling pairs of supermassive black hole whose gravitational signal is detected by LISA by using the modulation of the X-ray emission that you expect to happen in the distorted and steered time-space produced by the merging of orbiting, by the pair of orbiting and eventually merging black holes. So that's where we stand in terms of my personal biased view of where do we stand in terms of the science case of Athena. Of course, that's my own biased view, but if you want an unbiased view of the science cases, you are welcome to join the next science events of the mission, a WFI survey, a symposium at the European Astronomical Society conference in Valencia in 2 weeks' time on WFI surveys from Rosita to Athena, and of course the big science conference on Athena in November. They both go ahead as planned, and the deadline for abstract for the Athena conference has been just extended to July the 5th. So, interesting times are coming. I don't know what's going to happen to Athena in the future, but Athena has been mentioned several times in this conference in a completely unsolicited way, and I cannot imagine that a strong instance of a community on this mission will eventually not allow to reach a solution that allows Athena to continue forward in the Athena science program and eventually being adopted and launched. So I thank you for your attention, and I'm glad to take any further questions.
Questions? Too shocked to ask. Piero Olivier.
Yeah, between the first talk and this one, so this one is the dream. For example, when you increase the coating, I mean the multi-layer should cost a lot, no?
No.
Oh, okay, great.
No, it will cost. Well, what do you mean a lot? It will cost a fraction of the total cost of a mirror, which is lower than 10% probably. So it's in a sense in the noise, because the point is that you need to coat the optics anyway. And the Cosine, the company in the Netherlands developing the optics, they have already installed the coating machine to be used for the flight program. And so having, essentially multi-layer coating means that instead of doing, one carousel round to just spray one coating layer of coating, you have to make several. Now, this takes time and may have an impact on the time of the time needed in order to manufacture the module. But we discussed this recently. It's an increase of a cost, but it's not a cost driver. And there is even the possibility, which would be within a relatively reasonable cost, to have a second, for instance, coating machine installed at Cosine. There would be space for it that would actually allow to decrease the time and therefore decrease the cost with a relatively small investment.
Okay, thank you.
Another question? Yeah. Go ahead. Go ahead.
Yeah, so how hard will it be to go from the half energy width of 8 arc seconds down to 4?
5.
Oh, sorry.
5. Well, I don't know an answer, but because this is, you have seen the evolution in the last months. It's not linear. You have many months where you are stacked at a given performance, and then everybody's moaning, oh, no, we have reached the plateau again. And then at some point, a breakthrough happens. Then you have to verify that the new recipe works, but then you stay on the same plateau for a few other months. So that's the way I expect the technology development to proceed. So now, why am I optimistic that there might be further jump improvements in the future? Because Cosine has just purchased, with ESA money, an IBF, ion beam figuring machine. This is a technique, a machine that allows you essentially to achieve a much better shaping of each individual plate that goes into the stack. And the expectation is that this IBF technique, which is regularly, routinely used by other X-ray optics technology, will allow you to get another jump. How big this jump will be, I don't know, nobody knows. When it will happen, also we don't know. So, in a sense, all the pieces in place to achieve a further performance level are already in place. So, if you like, the nominal answer to this question is the difficulty is 0, because we have already all the recipe in place. But how much time we will need to learn, how much time we will need to learn how to, master this technique, and which jump in performance it will produce, it's still unknown at this stage.
Okay, thank you.
So I wanted to ask about the multi-layer coating again. When I saw that effective area, I was actually a bit horrified, because the one place you don't want a broad bump is at 6.5 keV with all the controversies about we'd have to absolutely get our calibration right. At least if you have a smooth mirror effective area through the 6 keV bandpass, you're not worried about broad residuals from your mirrors. But if we put a broad residual in our mirrors, calibration is going to be absolutely important.
Okay, I disagree with that. This has been a concern for many years. And this is the reason why originally the ASST was reluctant to make a recommendation on the ASST. Then we had the ASST organized a workshop with calibration experts, in particular with the New Star colleagues, and we asked them the very same question. Do you think that if we introduce a structure like this in the effective area, this will be difficult to calibrate? And the assessment is that it will not, everything is difficult, of course, in Athena by definition, but it's not conceptually more difficult than getting the proper effective area here. Yeah. Because this feature is truly broad. Yes. And we are going to have measurements on a much, much more refined energy resolution than we had for prior instruments, because we have anyway to be able to calibrate the fine structure features at an energy resolution of 1 eV. Yeah. So it is conceivable to have ground-based calibration of this bump at a few eV resolution that will allow you to calibrate quite accurately. And in flight, you have the X-IFU. Yeah. You observe the 3C73 or whatever with X-IFU. Yeah. You will know this bump, or maybe 3C73 is not a good example. Yeah. A blazar object, a blazar object in this range, and then one of your, okay, I don't have to explain you, because I've been done this working for, 1 decade. So, in flight, we will have this measurement with X-IFU. Yeah. So we don't believe that that's a serious concern if compared with the loss of effective area in a critical energy band regime.
Okay, thank you.
But it's a very fair concern, and we spent 3 years discussing this point in the ASST before we took the decision. Yes, yes. We will not be the case for Athena, hopefully.
Other questions? If not, let's thank Matteo again.